The multiverse as an atheistic response and why conservation laws refute it. Summary. Atheists appeal to the multiverse to avoid the evidence for God, from the Big Bang and the fine-tuning of the universe. However, conservation laws falsify the multiverse. So, conservation laws point back to God. Introduction. Atheists often appeal to the multiverse hypothesis as an alternative to the theistic interpretation of the Big Bang and the fine-tuning of the universe. The multiverse theory posits that our universe is but one of an infinite number of universes, each with its own unique laws and constants. This vast ensemble, some argue, could theoretically generate at least one universe like ours, thus explaining the apparent design and fine-tuning without recourse to a designer. However, the multiverse hypothesis encounters significant issues when examined under the lens of conservation laws, which point to the need for a transcendent cause, a rational basis for the existence of the universe that is consistent with the evidence we observe. Here's why. 1. The appeal to the multiverse to avoid evidence for God. The Big Bang and the fine-tuning of the universe are two major phenomena that many theists argue point to a divine creator. The Big Bang. This model suggests that the universe had a specific beginning, a singularity from which time, space, and matter emerged. This beginning implies causation, which aligns well with the concept of a creator who transcends time, space, and matter. Fine-tuning. Physicists have observed that the constants governing our universe, like the gravitational constant and the cosmological constant, appear finely calibrated to allow the existence of life. Even minor deviations in these constants would make the universe uninhabitable, a fact that many interpret as evidence of purposeful design. For atheists, the multiverse theory provides an escape from these theistic implications. By suggesting that there are potentially infinite universes, each with different laws and constants, they propose that the fine-tuning observed in our universe is simply a matter of chance. If countless universes exist, then it's conceivable, they argue, that one would emerge with the precise conditions necessary for life. 2. Why the multiverse hypothesis faces challenges. The multiverse hypothesis, while mathematically conceivable, faces significant philosophical and scientific challenges, including lack of empirical evidence. There is currently no observational evidence for the existence of other universes. The multiverse, therefore, remains speculative and beyond verification, unlike the observable fine-tuning within our universe. Infinite regress. The multiverse hypothesis does not address the fundamental question of causation. If a multiverse generator exists to produce universes, what created the multiverse generator? This line of reasoning leads to an infinite regress without a final uncaused cause, failing to provide a coherent explanation for existence itself. 3. Conservation laws as a refutation of the multiverse. Conservation laws are foundational principles in physics, describing how certain quantities remain constant over time in an isolated system. Two primary conservation laws directly challenge the multiverse hypothesis. Conservation of energy. This law states that energy cannot be created or destroyed in an isolated system. If the multiverse is posited as a self-contained system, it cannot spontaneously generate universes without violating the conservation of energy. A universe, or a multiverse, that requires external energy input to create new universes would imply a source beyond the multiverse itself, pointing to a transcendent cause. Conservation of information. Closely related to the second law of thermodynamics, the conservation of information, sometimes referred to in quantum physics as unitarity, suggests that the information in a closed system remains constant over time. For a multiverse to randomly generate universes with varying laws and constants, it would need a mechanism to input new information continuously. But where would this new information originate? Conservation laws imply that information cannot simply materialize without an external source, challenging the notion that a multiverse could randomly generate complex, finely tuned universes. 4. Conservation laws point to a transcendent source. The failure of the multiverse hypothesis under conservation laws directs us back to the concept of a singular, transcendent cause. Here's why. Necessity of an uncaused cause. conservation laws suggest that everything within our universe, and any proposed multiverse, operates within constraints, unable to create energy or information from nothing. This aligns with the concept of an uncaused cause, a necessary being that exists outside of and independently from our universe. This being, transcending physical limitations, is what many theists identify as God. Fine-tuning and conservation. Conservation laws imply an underlying order and rationality within the universe. The fine-tuning we observe is not only unlikely but highly ordered and informational. Conservation laws suggest that this order could not arise from a random, unguided multiverse. A cause or mind outside physical law would be necessary to account for the laws and fine-tuning we observe. 5. Specific examples highlighting the problem with the multiverse. To further illustrate the difficulty of the multiverse hypothesis in light of conservation laws, consider these examples. Example of energy conservation. If energy within our universe cannot be created or destroyed, the idea of a universe-generating multiverse, operating without any additional source of energy, contradicts this principle. To generate universes would require energy, suggesting either an infinite source or a violation of conservation laws. Example of information conservation. In quantum mechanics, information must be preserved, even across events like black hole evaporation. If universes could be randomly generated with varying laws, information would have to originate without source or preservation. This random appearance of informational complexity without conservation contradicts observable principles in quantum mechanics, pointing to the need for an external, informational source. Conclusion. Conservation laws direct us to God. Conservation laws, fundamental, observable principles in our universe, strongly challenge the coherence of the multiverse hypothesis. Rather than providing an escape from theistic conclusions, the multiverse, if examined carefully, seems to require even greater explanatory resources, pointing toward an ultimate transcendent cause. Conservation laws reveal an underlying order and uncaused source, aligning with the concept of God as the origin of the universe, not as a stopgap but as a necessary, rational foundation. Far from removing God from the equation, the failure of the multiverse hypothesis under conservation principles ultimately points back to God as the rational explanation for the universe's origin, order, and fine-tuning. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.